Hello, everyone. A very warm welcome to this training program on learning SQL. So SQL for data analysts and data scientists. We will start from the very basics, try to understand what is a database, and then how SQL helps us interact with the database. And then, of course, we will build on top of that and proceed towards the advanced concepts. Now, the agenda for this module, or what we're going to look at today, is we will keep it simple, basics, try to understand certain things, certain terminologies, which we are supposed to be familiar with while working with SQL. First of all, why do we need this SQL? What is SQL? SQL is a short form of structured query language. It is the short form of structured query language. It is a language that is used to communicate with data that is stored in relational databases. So now we'll start with the very basic. What is data? And why is it that we need data? Right? These days, the kind of times that we are living in, almost everything that we do generates data. The moment you are connected to the internet, every activity that you perform generates data. So let's say you're trying to log into your bank account. Okay, you will have to give your user ID and password. And that password which you enter gets validated against a database, because these passwords and IDs are stored in a database against which whatever you enter is compared. So your activity is you're trying to log in, but behind the scenes, there is a database with which this data is being validated, and then only it allows you to enter, right? So we need databases to store the data that is important and that is necessary. And everything we do generates data. How many times we log into our account, whether you visit to a hospital, even if when you go to a hospital, you are basically generating data. These days, everything, all the reports are maintained electronically in databases. So when every activity that we do, every time we swipe our debit card, every time we swipe our credit card, make a transaction, visit a website, search for a product, everything generates data. And this data needs to be stored in a place so that it can be analyzed further. And some meaningful inferences can be drawn out of that data. Some informed decisions can be taken by analyzing that data. Some prediction models can be built using that data to predict the future. So data is necessary in the kind of world that we are living now. Data is generated, and the data that is getting generated has to be stored. The place where it is stored is a database. For example, suppose let's take one small example and generate some data. Let's say there's an organization and they are recruiting employees. So if you are recruiting an employee, there's a person who's joining my organization as an employee. I will need to know about that person. I will need to know some information about that person. Okay, so like, what is the name? Name of the person. This is a data point. Names of the employees will be stored in one field. And this field, the column with where the employee name is being kept, it is going to have certain type of data. So if employee name is going to be a column where I will store the names of employees, it is going to be of certain type. So that is referred to as data type. Every data point, every value has a type. Data has a type, which is called as data type. Now, what do you think will we enter under employee name? We will enter alphabetical data, isn't it? We will enter alphabetical data, name of the employee. So the data type would be char, character. It is of string. Here we're going to enter alphabetical data, which means it is string or textual data. So in technical terms, in SQL language or in structured query language, this is called as char. The data type would be char, or we can give varchar. Or in some tools, you can just say this is text. Okay. What else? The employee, let's say, has been given an ID, employee ID. An ID is basically a number by which an employee is uniquely recognized. It could be purely numerical. It could be alphanumerical. Let's say the ID of this employee is something like B56850. So this is alphanumerical data, right? It is a combination of numbers and alphabets. So when we have alphanumerical data, this also is stored with the data type given as string. So in technical terms, again, based by the structured query language, char, varchar, or text. Okay, then the employee might, let's say we also are making a note of the age of the employee, age. What kind of information will be stored in the age field? Number of years. So let's say under age, we would like to keep a track of how old the employee is with respect to number of years. So this is going to be an integer value, right? It is going to be a whole number. So the data type, it is numerical, of course, and under numerical, I'm saying whole number. What is a whole number? Something that will not have decimals. So technically in SQL, this is stored with the data type as int. Okay, int meaning integer. Then let's say we're also going to have the salary of the employee. Employee is being paid some salary, so salary. Now what could be the data type of this field? What kind of data would we store here? Salary. It could be a whole number, but it is also possible that there could be some decimals. We can't rule it out. There could be some decimals. So this is numerical, but it will allow some decimal numbers. Again, in SQL, we call this as float. Or depending on the system, you just can call it numeric. Okay. What else? We might want to store the date of birth of the employee, the date of birth. Now, what will be the data type of this field where we are storing the date? Let's say, for example, the employee was born on 4th of April, 1990. So the data type of this field is going to be date. And let's say when this employee swipes in or punches in on a daily basis, they log in for work, the timestamp of when they are exactly logging in is recorded. Usually organizations track the number of hours an employee is working per day, right? So they have a punch in time and they have a punch out time. So we need to know exactly when the person is logged in and when is the person logging out, punching in and punching out. So that would be, let's say the timestamp, okay? Time of login. Now, what is it that we're going to have here? We're going to have the exact time, right? Let's say on 13th March 2023 at 5 p.m. this person logged in, 5 p.m. IST. So the data type of such fields which hold the date and the time is timestamp. Okay, so we are living in a world where a lot of data is being generated. Look at how much data we generated for one employee joining the organization, or an employee who's working in an organization. There could be a number of other things. Okay, let's say we also need to know whether this employee is eligible to vote. So eligible to vote. Is this person eligible to vote? Now, what kind of data will be stored here? Either the person is eligible to vote, where it would be yes, or the person is not eligible to vote, where we will say no, you're not eligible to vote. There is no third bucket. There is no third place to go. It's either there is the eligibility or there is no eligibility. So when we have such information, wherein only two possibilities are there, yes or no, Y or N, true or false, or let's say we are indicating, if the person is eligible, let's say we'll indicate it with 1. If the person is not eligible, we are going to indicate it with 0. So when we have such information that is supposed to be stored in a field, the data type would be Boolean. Okay. So why are we talking about this? Because data cannot be randomly saved in any format. Every field which contains data will have a type. There's a type that is associated with it, which is called as the data type. And depending on what data type is defined, only that type of data can be stored in the field. So if you have defined the data type of a field as integer, you cannot put alphabetical data into it. You cannot put decimal values in it. You cannot put date. There is a reason why data type is assigned. To make sure that there is consistency in the information that is being placed in the column. Right? This is a very simple example. All of you would be familiar with such examples like college databases, where the details of students are kept, staff members are kept, course details are kept. So you pick up any example in your real life scenarios on a daily basis, whatever you do, you are generating data. So how do we store this data? What are the different types of data? I'm not talking about data types now. We understood data type. It is the type of the information that can be stored in a field: alphabetical, alphanumerical, integer, decimal, date, timestamp, Boolean, etc., etc. We have binary values, etc. Now I'm talking about what are the different types of data that we work with. Okay, types of data. So there is structured data. Now, what is structured data? When your data is neatly organized into columns and rows and stored in tables. Let's create structured database now. Let's create one structured table. I have my data. Now I need to enter this in a proper format so that it can be accessed by all the employees in the organization, so that data analysts can retrieve the data and work with it. Data scientists can go ahead and build prediction models on this data. So for that, first of all, we need to store the data in some place. Simplest of the database would be a spreadsheet. If you just look at one spreadsheet, okay, application, an Excel document, how do we store data in an Excel? So suppose this is my database and I'm supposed to store the employee details in here. So employee name would be one column. Employee name would be a column. What is the next thing we put? Employee ID would be another column. The age of the employee will be another column. Date of birth of the employee would be another column. The salary being given to the employee is a column. Eligibility to vote, okay, or eligibility for a hike, something like that, okay, would be another column. So data is organized like this into columns. Each field will hold a data of a specific type, whether it is character or integer or floating number or date or timestamp, etc. Let's say there is an employee A with the employee ID 1, age 30, some date of birth. some salary. And yes, this person is eligible to vote. Okay. Let's say there's another employee who has joined for whom we are making an entry. Employee 2, age maybe 20. Okay. Some date of birth, some salary being offered. Yes, this person is, well, let's say this person is not yet eligible for any sort of perks. Okay. The person has just joined, so not eligible for any sort of additional perks being given by the organization. Not yet. Maybe he has to serve the probation period and then will be eligible. So this, what I'm creating here, is called a table. Okay. This whole thing where we are putting in the data is referred to as a table, and tables are also referred to as entities. It is also called as an entity. Each individual column, employee name, employee ID, age, these are columns. So the table contains columns, which are also called as fields or attributes. So vertical things, these are columns or fields or attributes. Now these horizontal lines, okay, the data that is organized in a horizontal way, the row, this is the row. So it is called as, these are called rows or records or tuples. Rows or records or tuples. Each record pointing to an employee, giving the information about an employee. So when you take data and store it like this in a nice format, tabular format, where everything is arranged into columns and rows. And do remember this nomenclature, it is important to know what is what. And every individual block here is a cell. Each cell is containing some value. Okay. So the whole thing is called a table or an entity, which contains columns or fields or attributes. And then the information is stored in the form of records or tuples. So columns are defining the structure and the data is stored as rows inside a table. Now, a collection of many such tables is a database. So maybe I have one table with all the employee details. Maybe I have another table with the department details, list of departments in the organization. Okay, maybe I have another table with the salary breakdown and what kind of salary I'm offering. Okay, 30,000. But what is the breakdown? How much of it is towards maybe what part of it goes to, DA, what part of it goes towards PF and all that. So data is usually split across multiple tables like this. And when we put all of these tables together in one system, in one place, all these tables encapsulated into one big storage. Individual tables encapsulated into one big storage. This is database. This is database. Sorry, my pen tool doesn't seem to be working. This is the database. Okay. Now, to manage this database, we need a system. A system that manages the data inside the database, the tables inside the database. That is database management system. Database management system. Okay. So a collection of tables is database. And to manage the database, you need a system that is called as a database management system. There are many database management systems which are available. If we look at the history, data is not something that started coming these days, right? Data has been around since ages, but a proper system to store the data has been emerging since the late 1960s, where IBM, they came up with a standard database system where the data can be stored, and which was later on taken forward by many other organizations, Microsoft, Oracle, etc. Now, to talk to the data that is present in the databases managed by the database management system, we need a language. The language that is used to talk to the data in the databases is Structured Query Language, SQL, also called as SQL. And it was developed by IBM and later it was standardized by many other people and companies. So there are different types of database models which are available, and relational database models are the most popular ones. We will talk about the models. Now, what is the role of a database? Let's say you have a query. Okay, you as the client, as a person who's using, for instance, Google. You're on the Google web page and you have a question in mind. You just need an answer to a question. Your question is, what is SQL? So when you type in your question from your phone or from your internet browser where you put the question, the request goes to Google server. Google server will not directly give us the response. It will in turn send a request to the database where all the information is stored. It will query the database. The database will retrieve information from the tables and provide it to the server. Now, Google server will take all those results and respond and return them, which we can see on our web browsers. It gives us a number of links and suggestions and definitions. So every request you place goes to the database because at the back end, it is a database that holds all the information which is getting queried. When you try to access the information from a database, you are basically querying the database. You're trying to retrieve the data based on some criteria, right? We're not retrieving everything. We don't want everything present in there. We want an answer to the question that we have in our mind, that we have typed in on that browser. As I was telling you earlier in the discussion, so when you punch in your ATM PIN to make cash withdrawal, whether that PIN is valid or not, correct or not, how does the system know? Your bank server is actually requesting the database. It is validating it against the list of PIN IDs present in the database. It's going to check against your name, what is the PIN? And then if you have entered the right PIN, which matches with the PIN that is there in the database, then only it will allow you to make the transaction. Otherwise, the transaction will fail. So databases play a very pivotal role in our day-to-day lives. Whether or not we realize it, they are there everywhere. Our data is being stored everywhere. Now, data itself is divided into three types. We have structured data. So when data is neatly organized into columns and rows, we call it structured data. And to talk to this structured data, we have structured query language, also called as SQL. So I hope what is SQL is clear. It is simply a language that is used to talk to data that is present in a structured format under different databases. Now, there are many relational database management systems like Oracle. Okay, there is MySQL, there is Microsoft SQL Server, there is PostgreSQL. Simplest one would be Access, Microsoft Access. There are n number of databases which are relational databases, and we can talk to the data present in any of these databases using SQL, structured query language. There is another type of data, which is unstructured data. Okay, so if you have structured data, then this is what we do. What if we have unstructured data? What is unstructured data? Data that is not stored in any particular format. Like, for example, documents, document databases, graph databases, just a collection of graphs, key value databases, or videos, video files. When you upload a video to YouTube, it is data. That video itself is data, but it is not in a particular format. Audio clippings, electric signals, images that are put on Instagram, posts that you upload to Facebook. the comments that people write. Okay, so these are all not in a structured format. So such data is unstructured data. And there are many databases where unstructured data is stored. Okay, and there will not be any relation as such between the entities or between the data that is being stored in unstructured format. Okay, there may not be a relationship. So we can't query them through SQL. There are databases like Cassandra. Okay, there are many actually different HBase or hives. You might have heard of the term Hadoops. Okay, Hadoops are used to store big data. Big data in the sense data that is huge in volume, huge in the variety, and it gets generated at a, the velocity at which it is generated is high. The veracity is high, the velocity is high, the volume is high. So big data. Then MariaDB. Okay, there are n number of things. I can just go on and on. There are n number of databases. We have MongoDB, so on and so forth. Now this list goes on and on. Neo4j, so on and so forth. Now, how do we communicate with data that is present in unstructured format without any relation as such? That is where NoSQL comes into picture. Now, NoSQL stands for not only SQL. Okay, so data is essentially of different types. Structured data is there, unstructured data is there, like video clippings, audio files, electric signals, images, posts, etc., which don't follow a specific format. And there's also semi-structured data. Okay, semi-structured data. Now, what is semi-structured data or semi-structured data? It would be a combination of structured data as well as unstructured data. So because it is a combination of structured and unstructured data, we can communicate with a part of it using SQL and with a part of it using NoSQL. Now, what would be the best example for semi-structured data where we have it in not a structured format, but also in a structured format, right? You can think of Wikipedia. If you visit Wikipedia, it is a place where we have data in different formats. See, we have images, we have audio clippings, we have, and look at this information. This is nothing but a table. It is a text table where data is arranged into columns and rows. This is not a table. This is just textual information. So this is textual information, but these are tables. What you see here, this is nothing but a text table where it is nicely stored as rows and columns. So we have structured data, we have unstructured data, we have images, we have audio clips, a lot of things. So when you have a combination of structured and unstructured data, we can say that this is semi-structured data. Okay, so as a part of this program that we are conducting from 360DigiTMG for you all on SQL, we will be learning how to communicate with relational database management systems. And we will be using PostgreSQL as our tool. As I told you, there are many databases. The core language remains the same. Okay, 70 to 80% of the time you will use the same statements and same commands to access data present in any of these database management systems. But tool specific, there could be some changes here and there. Okay, tool specific changes will be there. Now in our program, we are going to install PostgreSQL on our machines, and we are going to learn everything about it, right from inserting the data into the database, to retrieving the data, to controlling permissions which other people are supposed to get on that data. Okay, to learning advanced concepts like how to join data from multiple tables, how to define constraints, key constraints, primary key, foreign key, check constraint, unique key, all these things, indexes, subqueries, So we will go from basics to advanced. Today is more like an introduction session where I'm trying to simply give you some understanding about what is data, why is it important to store it, and after having stored it, why is it important to retrieve it and analyze it. Okay, I will show you PostgreSQL's installation now. Anybody who's interested, you could do it parallelly or you could install it later on by watching the video. So anyway, the session is happening in YouTube live. So all the videos will be available in our YouTube channel. And I request you all to subscribe to the channel. If any of you has not yet subscribed, please do hit the subscribe button and turn on the notifications so that whenever we have such events planned and whenever we put some information, you get notified and you can watch it immediately. So let me show you PostgreSQL's installation now. For this, I'm going to take you to the link. So in order to install PostgreSQL on your machine, which is a relational database management system, using which we will learn everything about SQL language, you need to go to this link, www.postgresql. You can call it as postgresql.org. Once you do that, it takes you to the website. Okay, now this is a tool that is open source, meaning you can just download it without having to pay anything. Okay, it is a free tool which anybody can just download. So there are different versions of the tool, as you can see here down, the latest releases, you can note them. There are many releases where frequently they keep upgrading the tool. The latest version of Postgre is 15.2, version 15.2. So when we hit the download button over here, that is what will get installed on our machines now. Okay, I'm going to click on the download button here. Now we are supposed to choose the operating system. Depending on which machine you are using, whether you're using Mac OS or Windows or Linux or whatever it might be, you have to choose the appropriate operating system. So this machine that I'm using is Windows. Therefore, I'm going to click on Windows. Okay, it brings me to the next page. This is the Windows installer for PostgreSQL. Now I'll have to click on this link. Look at this. What is it telling? Download the installer. So we'll have to install the tool by clicking here. Download the installer. After that, we can see the version. So whichever version you might want to install, you can go ahead and install. I'm going to install the latest version, 15.2. Again, depending on the operating system that you are using, you have to click on the appropriate link. Now, the support for a 32-bit Windows machine has been stopped. So if you are using a 32-bit Windows machine, you will not be able to download it. So I'm going to click here to download the executable file, the .exe file. There, it has started the download. For Windows 64-bit machine, I repeat, the support for 32-bit machine has been stopped. We cannot install it if we are using 32-bit machine. Okay, meanwhile, anyone who hasn't subscribed, you might want to go ahead and hit the subscribe button. MySQL you need. Okay, I'm just checking the messages here. Yeah, it is basics to advanced. No, not Zoom link. You have to connect via YouTube itself. That would be good. And MySQL, if you want, I will show the installation of MySQL also. One of the days I will show. Okay, MySQL. What is the difference between SQL and MySQL is the question. MySQL is a database. It is a server where the data is stored. Like Oracle is a database. It is a company which has its own database, right? Oracle. Like PostgreSQL is a database. Microsoft SQL Server is a database. Similarly, MySQL is also a database. Okay, then what is SQL? It is a language where we write the commands in simple English language. Okay, like it was actually called a structured English query language. Then it's called SQL in short. Okay, structured query language. So it is a language which is used to communicate with the data that is stored on these databases, which could be MySQL, which could be Microsoft SQL Server, which could be Oracle, which could be MS Access, which could be PostgreSQL, so on and so forth. IBM's DB2. Okay, even to communicate with data present on IBM DB2, you need to know SQL. So SQL, it is a language which is used to talk to the data that is present on various databases. Okay, I hope you all got it. Yeah, Srinivas, MySQL is a database. Okay. Sayanti, if you have MySQL, there is no problem. You can install Postgre also. It will not create any conflict. I just did. What are all the topics that we're going to cover? I just mentioned it. Okay. So now that the installation is done, I'm going to open it. Okay, I'm going to run the executable file, run the installation. It is giving me a prompt. Okay, it's telling me, do you want to allow this app to make changes to your device? I will click on yes here. Maybe that part wouldn't be visible in the screen. So you see, it's trying to install it. It's going to open the installation wizard. Here, the setup, the installation wizard, the setup wizard has opened. I'll have to click on next. And all the necessary files will be installed under your C drive, under program files, under a folder called as PostgreSQL, and the version is 15. I'll click on next. You need not change that path. What are all the things that we might want to install? Okay, we will install PostgreSQL. These are client server databases. Okay, so we need the server to be installed. We'll keep it on our local machine, install it. pgadmin 4 is the client through which we interact with the PostgreSQL server. If you want, you can keep the command line tools. Stack Builder is not necessary. We can uncheck that and proceed with the remaining things. So the data will be stored in so-and-so path. I'll click on next. Now you need to set up a password. You are installing the machine as an administrator on your local machine. Okay, you should have admin rights to make installation, and you need to set up a password. You will be the super user, and the ID given to the super user is Postgres. In Microsoft SQL Server or in MySQL, it would be called root. So those of you familiar with, who are already working with MySQL, you will have the username as root, right? R-O-O-T. Here it is Postgres. I need to set up a password. I'll just give some password. Password should be a combination of, capital letters, small letters, numbers, special characters, and all. So it would be a strong password, and you need to remember it. Okay, it's better that you write it down somewhere. Then I'll click on next. The port number. So there are some dedicated ports through which the client server communication happens. The dedicated port for Postgre is 5432. Will not make any change there. Just click on the next button. Default locale. So depending on your system locale, it will be taken. If you want to choose a specific locale, you can do it. I'm just going with default locale, which is English India, or I can actually go and specifically choose English India. Okay, those of you in the US or joining from different locations, you can set up your system locale. Then click on next. So it's giving us the installation summary, the pre-installation summary. And when I click on next again, setup is now ready to begin installing PostgreSQL on the computer. So we'll just click on next, and the installation has started. It's going to take a moment. I don't think it will give any such error here, Sampada. Shouldn't give an error. If you have MySQL Workbench, you may not have to download Postgre, not necessary. Few commands will not work the same way on both the tools. Okay. So I'll point out when we come to such commands which may not work the same way on MySQL, I will let you know. Like the auto increment command, etc. Okay. As I told you, the language and its structure mostly remains the same across all the databases. However, there are few commands as we proceed towards advanced concepts. There are few commands which are specific to the tool, specific to the database. Like, for example, if we would like to increment a number automatically, the keyword used in MySQL is auto increment. But the keyword that is used in Postgres is serial. So as we proceed towards advanced concepts, few changes happen from tool to tool. It is not like you write a query in one tool and it can be usable everywhere else on all other tools. You may have to make a few changes. So you need to refer to the documentation of that specific tool with which you're working and accordingly tweak the SQL to be compatible with that tool. Okay, that is one small problem. Okay. So I'm going to click on finish. The setup is done. And once the setup is done and we have installed it, now when I go and search for it here, right, I need to search it as PG admin. This is the icon for PostgreSQL, this elephant face kind of a thing. So PG admin. Once I click on it, the tool, the interface, okay, the editor will open. No, it's not. If you install both MySQL as well as PostgreSQL on your machine, there will be absolutely no problem. You can have multiple databases. No problem. Now, those of you who already have MySQL Workbench or MySQL Shell, you can work on that. You need not install Postgre again. But if you want to work specifically on this tool, Postgre, you can install it. There is no harm having multiple databases. Clear? There will be no problem. You can install both of them. It's not mandatory though. Okay, first session, so I'm just going a little slow. Tomorrow onwards, we'll start off with the commands. Okay, we will see how to create tables. We will see how to insert data into the tables. And while inserting the data, what are the things that we need to bear in mind? How do we define the data types? All these things. Yeah, if you're using Oracle, no problem. Continue, no problem. Look at this. The moment we open the editor, we are asked to enter the password. So you need to enter the password. Better to remember it. Don't forget it. If you forget, you can, I think you'll just have to uninstall and install it again. Without losing the data, you can uninstall. Megharaj, more or less the same. More or less the same, but a few changes could be there. Yeah, Pradeep, you can use Oracle, no problem. You can use Oracle. Okay, so this is what the editor looks like, okay? And we have an explorer kind of a thing on the left side of the screen. Look at this option on the top left corner. It is called servers. Now, when I open it, okay, these are the two servers which are already present. See, because I already had 14 and then now installed 15. Okay, it's showing me both the servers, but they are not active. So you need to click on it in order to activate it. Once you click on it and you expand it, okay? Again, it's prompting me to enter the password, which I will do and save it and click on OK. Now you see PostgreSQL 15. And you can see the Explorer, right? This is the server, and there will be one default database present in the server with the name Postgres. If we want, we can create tables over here, or we could create a new database. So today, I'm going to show you how to create a new database in the server. We just go to the databases option, right click on it, and select the option to create database. Sarath, maybe it is not compatible then. Here we give a name to the database. Let's say practice. Okay, we can give a name to the database. And who is the owner? The super user, the user ID with which I'm logged in, that is Postgres. So I'm not changing anything else. I'm just creating a database by providing a name to the database. And I'll click on save. Okay, so you can see the database and look at the number of databases. It has increased to 2 because we have 2 databases here. Postgres was a default database which was already available. And I created a new database with the name practice where I will store all my data. Now, when you go to the top, when you just go up to the toolbar kind of a thing here, this is the icon for query tool. Okay, this is the icon for query tool. And when you click on that, the editor will open. The query editor will open. And here we type in the commands. We put the SQL statements. And generally the output and notifications and any error messages or success messages, they will come down here. If you want to give slightly more space to the query editor, you can just go to this border and increase it in size. Click and drag. Click and drag, and you can increase it in size or you could reduce it in size. This is movable. This is movable. And I'll leave it here. This also, the Explorer side, if you want, you can reduce it in width or you could increase it in width. If you feel it's taking too much space, you can just reduce it in width. So both of them are movable and you can adjust them. Now, how will I know what is the database that I'm working with and on which server am I working and what is the user ID with which I'm logged in over here? I have opened the server and I'm trying to interact with the server, but what is the server that I'm connected to? So we need to see up here. So the name of the database that I'm working with is practice. And the user name is Postgres. At the rate, the server that I'm connected to is PostgreSQL 15. Okay. So the first part over here is the name of the database. It is the name of the database. Followed by this slash, what you have here is the name of the user, the person, the ID with which we are logged in, and the ID with which we are accessing the server. So this is the user. Then there is an @ symbol. Followed by @ you can see PostgreSQL 15. That is the name of the server to which I am connected. Okay, as I told you, there are multiple versions. I already have 14. So today when I installed 15, it's just taking it as an add-on. Okay. So if you are installing it for the first time, you may not see 14 at all. You will see only 15. This notation is very important because it helps us understand what we are dealing with what user ID the person is trying to access the information on the particular server and which database are we working with. All right. Now I'll just change that. You'll try to figure out what I'm connected to. So if I choose Postgres, and then click on the query tool. Okay, if I choose Postgres and click on query tool, Now you see there is a change. What is the change that you note? There is a change in the name of the database. I'm connected to the database Postgres. User ID is of course Postgres only. And the server that I'm connected to is PostgreSQL 15. No, we will be practicing it on PostgreSQL only, all the commands. Your laptop, okay, it's not supporting, is it? The installation is not getting supported. There is no workaround as such. They have stopped the support for 32-bit machines and for older versions of the operating system. I'll do one thing. I will show MySQL installation also because some of you have trouble here. I will show MySQL installation tomorrow. So for those of you for whom Postgre is not working, you could maybe try out MySQL and download that and work there. Okay. Now suppose I open this server. Okay, suppose I open the PostgreSQL 14 server and check the databases under that. Okay, there are some databases. Now, if I click on the query tool, now you will see the query tool, the editor will accordingly get updated. So the database I'm connected to is practice, right? This one, I was connected to this one. The user ID with which I'm connected is Postgres. And the server to which I'm connected is PostgreSQL 14 server now, this one. From here, I went into databases, and from there, I went to the practice database, and from there, I invoked the query tool. Yeah, Meghraj, that is what I was trying to answer. I will be working on Postgre throughout the course, but because some of the participants and you are not able to use Postgres, tomorrow I will show MySQL installation also. Okay, so whatever I'm doing it here on Postgres, you can do it on MySQL. And wherever some changes will be there, I will point it out. Because the syntax is not 100% similar in both the tools. The syntax will be slightly different on each tool. So wherever that difference comes, I shall point it out. So even if you're using MySQL, it shouldn't be a problem. I think you should comfortably be able to attend the course. Okay, Meghraj? All right. So this was something I wanted to mention, the query editor. Now, how do I go from one query editor to another? I opened so many of them. Maybe I want to go back to the previous one. So here, all the list, you can find the list here. Here. Okay, look at this. Look at this. So 3 different query editors I had opened. This is one. This is another. Or you can just click here. Okay, and you can see the connection and point it out. You know, look at this. Okay, or we could make a new connection from here also. Like this. Look at this. So these are query editors. Yes, Pankaj, query would be similar, but not 100% similar. Few differences could be there from tool to tool. All right. So let's try to create one table here. Very basic statement, I will say. I am using the practice database on the PostgreSQL 15 server, and I'd like to create a table. So I'll say that I want to create table. Okay. And then followed by that, we need to give the name of the table. I want to create a table with the name employee. Let's see whether this will work or not. And most of these client applications, okay, where we write the queries, they are user friendly and they use a color coding. Okay, create is a keyword, table is a keyword. So they are coming in purple color. Now this color could be different on each tool. Okay, in other tools, you may get blue color, you may get red color, etc. Here it's purple. And it's very, very user friendly. The color encoding is pretty user friendly because when you make a mistake, or let's say you look at this, I remove the character E It's no longer purple. So I know that something is wrong. It's very, very easy to identify errors. When you have simple queries, you may not be able to appreciate it much, but when you're writing really lengthy queries, this color encoding helps us identify the mistakes very quickly, and it will help us, debug easily. So I'm saying I would like to create a table with the name employee. To run the command, we need to select the command. Okay, select the command and execute it by clicking on this play button. Once I click on the play button, you see what has happened. It's saying there's an error. Okay, we started with an error. What is the error? There is a problem with creating the table employee. Okay, let me run it again. There is still an error. Why? Because I'm saying that I want to create a table, but I'm not telling it what will be the structure of the table. We can't just say create a table. Table needs to have some columns in it. At least one column should be there. Here, I have not specified the list of columns. So it doesn't know what to do. It's confused. We need to provide the column list. So we open the bracket and then we can provide the list of columns. Let's say I want to keep employee name as a column. And then we have to give the data type. Name will be character. So I'll just call it varchar. If we want, we can specify the length. So we are saying it can't be beyond 20 characters in length. Varchar means varying character, which means suppose though you have reserved 20 bytes to store the name, if the name has only 4 or 5 characters, it will not block all the 20 bytes and unnecessarily waste the space. It will use only 5 bytes or 6 bytes depending on what is the size of the name. Let's say this person's ID or employee ID, and I would like to keep this as an integer. So now it knows that the table employee is going to have 2 columns. It's going to store the employee name and the employee ID. Now when I run this command, it works. Okay, database is already selected, Pankaj. We don't have to select the database explicitly here because after selecting the database itself, I clicked on the query tool. I'm already connected to the practice database under this server with so-and-so username. So it knows that it's supposed to create the table employee and keep it in the practice database. That information is already provided. Okay, so database, we don't have to again explicitly specify over here. It is understood. And the table is created. So let's cross-check whether or not it is created. How do we cross-check? I created it in the database practice. I'm just going to right-click on it and refresh it. Now I will go to schemas. And under schemas, we have to go down to tables. Look at that. One table got created with the name employee. And when I further expand columns and see, these are the 2 columns that are present in the employee table. Okay, so today we had an introduction to the concept of what is data. What is data type? It is the type of the data that will be stored in a column. And in general, what is the different types of data available? Structured, unstructured, and semi-structured. To talk to structured data, we need a language, that is structured query language. We saw installation of PostgreSQL, and then we saw how to choose a particular database in it, how to open the query tool, and how to create a table, a simple table with just 2 columns in it. So here I shall stop, and tomorrow when we meet, we will look at what all constraints we can put while creating a table, how to insert data into the table. Okay. So thank you all so much. We'll see later, Shiv. Okay. And I request you all to kindly subscribe to the channel. And if you found this session helpful, please do hit the like button. It will give us a lot of boost. It will, help us come up with many more such sessions for all the learners. Thank you so much, everybody. Please do subscribe and hit the like button. I'll see you all in the next session. Thank you.